Kia ora whanau. This video is all about calculating probabilities of questions that are about the normal distribution. We will be using a calculator for this, so that's hence the label GC edition or graphics calculator edition. Any calculator will do, but I have used the Casio graphics calculator of the model 9750 G2. Anyway, let's get cracking. We are going to consider 4 cases. Take a moment just to soak in that picture there. Alright, let's get cracking with case number 1. Sorry about that, there we go. Now, number 1, the length of branches from a Kahikatea tree plantation is assumed to be normally distributed with a mean of 1.8 meters and a standard deviation of 0.18 meters. Calculate the probability that a randomly selected branch is between 1.8 meters and 2 meters. Now once I've read the question, I have then drawn a sketch there. It is really important to visualize what you are looking for. Now once you have this visualization or this picture correct, it becomes incredibly easy once you get some practice to use the graphics calculator to answer this question. So you should be able to do it just like that. So there's my shaded area that I want there. So remember, I want the probability between 1.8 meters and 2 meters. Alright, so have your calculator ready? And here's how to get to the screen that you want. So if you're in the main menu, you select Stat, then DIST or distribution, then you want NORM, which stands for the normal distribution, and then you want to select NCD, which stands for normal cumulative distribution, or we're adding up individual normal probabilities. So you should get the screen here. You may already have numbers in there from a previous problem that you've tried, but if it's 0, then we need to start, either way we need to start filling in the numbers that we need. So here is what you should have. So our lower number is 1.8, our upper number is 2. Remember, we're looking for the probability between 1.8 and 2, standard deviation and mean that is stated in our question there. Alright, so next screen will give you a probability. So you look at that probability there, 0.3667. That will be our answer. Note that it gives you the Z values as well. So if you were calculating the probability that you just found using a standard normal distribution table, then you would have to use that Z value of 1.111 and the table itself. But we don't need to do that. So just to reiterate, this is where we've gone. That's the probability that we want. And there's our picture again, and the shaded area is equivalent to that probability there, 0.3667. Cool, let's go to case number 2. That's obviously correct. Here we go. Same scenario. This time we are calculating the probability that a randomly selected branch is between 1.7 meters and 1.9 meters. There's our diagram. That's what it looks like. There's not much more to say about that really, so let's press on. Again, we're in our calculator. If you start from scratch again, you will need to go to the main menu. So to get there, again, press the menu button. Stat, DIST distributions, NORM for normal distribution, NCD for normal cumulative distribution, or adding individual normal probabilities. There's your screen there at the end where we need to enter some values. So those are the values that you want. Remember, we are looking for the probability or shaded area between 1.7 and 1.9. There is our mean and our standard deviation as per the problem. And there's our answer there. Probability of 0 is 0.4215 rounded to 4 significant figures. There's our diagram, and there we go. Apologies, there's a slight error there. It should be 0.4215. Apologies for that. Case number 3. Same scenario again. However, this time we are looking for the probability that a randomly selected branch is larger than 2.2 meters. So we are looking for the right tail of this distribution. So anything that is above 2.2 meters. So you may already have guessed what values you want to enter into your calculator, but let's see for sure. So in terms of the values that you want to enter, our lower number is 2.2. That is because in our shaded area, that was the leftmost value that we wanted. Now our upper number is going to be this crazy thing here, a lot of 9s. Now what the heck does that mean? Basically the normal distribution keeps going on to infinity. So we want to use a very large number there. So our mean and standard deviation are as before. So in terms of the final answer there's a diagram again. We will get 0.01313. So again, we have our Z values there. But that can be used for later reference, or actually you don't really need it. So let's go on to case number 4. The length of branches from a Kakatiya tree plantation is assumed to be normally distributed with a mean of 1.8 meters and a standard deviation of 0.18 meters. Yes, I just read that again. However, it is always important to read the question. You need to read the question very carefully, as you may be calculating the wrong thing. So, there's my diagram. What this diagram is showing me is the probability that a randomly selected branch is smaller than 1.45 meters. Now again, as long as you place 1.45 to the left of 1.8, it doesn't matter, it's just a sketch. Remember, it's a visual aid to help you. So again, you can call this the left tail. Let's go straight to our graphics calculator. Remember our steps. And this time our upper number is going to be 1.45. However, as we go to the left, the normal distribution also goes to infinity. But at some point we're going to cross over that 0. So when we cross over from positive to negative, hence we get the negative. And a very large negative number is what I've put there. Negative 9999999. Mean and standard deviation are as before. And here's our screen that we should get. There's our diagram, and that is our probability that we want. 0.02592. Thank you for watching.